Okay, this is Unit 9, Topic 11, Quantitative Electrolysis Notes, aka some stoichiometry with electrochemistry. So,
Professor Lane will take you to school. AP Chem is chemical.
So first, we need to talk about what really we were measuring. So, in certain problems, they'll give us a current, which is the amount of charge that passes through the cross-sectional area of a medium per second, which essentially just means how electrons are flowing. This I right here, this big I, sorry, just to make it clear, is our current, and we'll derive the units from these other units that we're dividing by. So our Q, our charge, is given in coulombs, named after a French guy, Coulomb, and that's how that's written. And we've already looked at Coulomb's law and stuff in Unit 1, so that should sound familiar. And then our time, chemistry, we deal with really small units usually, so this is in seconds. And so a coulomb per second is how we denote the current. So this is seconds, and this is coulombs, or you can just call this C. A coulomb is also equal to C. And so if we have coulomb per second, we can say that this is C over S, or if we want to get really fancy, we call it an ampere, which is named after another chemist or physicist. And then we have this constant, Faraday's constant, that's really useful in electrochemistry because it tells us how many electrons are present in 1 mole of any substance. So Faraday's constant is 96,485 coulombs for every 1 mole of electrons, and this will make our calculations a lot easier. Sometimes you'll see it rounded as 96,500. That's essentially the same thing. Once it gives us the same number to a certain number of significant digits. So that's what we kind of want, right? That's what we want is consistency. So yeah, let's get started. A, how much charge passes through the cross-section of wire that is carrying 0.987 amps of current for 12.3 minutes? So first, what I would do is convert 12.3 minutes into seconds, but first we are going to get our amps. So our amps are coulombs per second, so we know that this is 0.987 coulombs for every 1 second, right? And then we know that we're going for 12 minutes, so we're going to multiply 12.3 minutes, and we're going to put minutes on the bottom because that's what we're going to cancel out. And this should look very familiar to you, and there's 60 seconds in every 1 minute. So 12.3 times 60 is 738 seconds. And then since it's asking for charge, so our charge is equal to I, and this is given on your equation sheet. I equals Q over T. So I equals Q over T. Oops, that's a weird T. And we know that our charge is 0.987 coulombs. 0.987 coulombs, and we're just going to divide that by our time, which is 738 seconds. And we'll get 0.987 divided by 738, which is equal to, or I'm sorry, we need to, yeah, no, this is correct, yeah, sorry. That's equal to 0.0013 amps. right. And then ask for how many moles of electrons pass through the cross-section. So now we will just use our Faraday's constant, and so for every 1 mole of electron, there is 96,500 coulombs. So our amps can be written in seconds, or coulombs per second, so it's 0.0013 coulombs per 1 second. And we are wanting to get into moles of electrons, so we're going to put our coulombs down at the bottom because we have coulombs up top, so we'll do 96,500 coulombs for every 1 mole of electrons. And so our coulombs are going to cancel out, and so I'm just going to divide by 96,500. And we get an answer, really, really small number, which makes sense because we're talking about electricity. It usually is pretty small, so it's 1.385, so I'm going to round up to 1.36 times 10 to the negative 8. And remember, we're in moles of electrons, so we need to include our units. Yeah, so that is our answer for B. I wrote B down here, so that's fine. Okay, so also, metals can be refined through electrolysis. So calculations can be made to determine how long it will take to produce certain quantities of pure metal. So let's just practice one. So it says, how long would it take to plate out 3.56 grams of silver from a solution containing silver ions when a current of 2.5 amps is applied? So we're solving for time here, so time needs to be our last step. First, we get this grams number, and we are going to convert to moles. So first we're going to do 3.56 grams of silver, and will I get the molar mass? Sorry, getting the molar mass. The weight is 107.86 grams for every 1 mole of silver. And then it says that we are turning into Ag plus ions, which means that we're going to have 1 mole of electron removed. That makes sense because silver only forms positive 1 ions, so it only has an oxidation number of +1. And so now we're going to say that for every 1 mole of silver, 1 mole of electrons is transferred. You don't have to include this step. This is kind of just a one-to-one thing, but I just kind of want to show how these cancel out. And using our handy constant we just figured out, we know that Faraday says that 1 mole of electrons will have around 96,485 coulombs. And so we now get our coulombs, and I will show it a different way. We could do it all in one place, but I would rather put this into our calculator first. So we get 3.56 times our constant. Then we're going to divide by our molar mass. And so we get this equal to 3,184.56 coulombs, okay? And so now that we have our coulombs, we have our charge, and remember amps are charge per second, so we know our charge, or our current, and we know our charge, and we're solving for time, so we're just going to use some algebra here. So we know that our amps is 2.5, this is our I, and we know that's going to equal the number of coulombs we calculated, so 3,184 0.56 coulombs. We're going to divide this by time. And really what we're doing in algebra is we're multiplying by t and dividing by 2.5, so they really are going to switch partners. And so then we'll have t equaling 3,184.56 divided by our 2.5, 2.5 amps. And amps are really coulombs per second. So if we say that, we can see our units canceling out, coulomb, and we are left with seconds. Divide by 2.5, and we get seconds of equaling 1,273. I'm going to round up to 1,274 seconds because it was 0.8. And if we wanted to convert this into minutes, we could say that there are 60 seconds in every 1 minute. So divide by 60, and we get about 21 minutes. And that is essentially how we do electrochemistry conversions. They're pretty fun. Definitely refer to your equation sheet for that I equals charge over time. Our current equals our charge over time. And don't forget to write out your units. Definitely need to see those cancel out. If you have any other questions, don't hesitate to ask me. And other than that, have a great rest of your day.